so here's Pat and Chris, and we're talking about the new design. And we've done a few things since you guys have seen it last. So more importantly, we were able to lay out the flex circuit and take a look at how it all connects with the ZIF connector here. And we've got the micro USB connector going in there. We've got a backboard here. We've got a zone where we want to reserve it for the micro SD chip.
Which we're having some challenges fitting in there.
Right, yeah, so we're trying to figure out how to get all that in there. Pretty tight quarters. And then we've got a rivet, and we've got the battery contact spring right here with this other board. And then this is the flex circuit that runs down to the other end. And what we'd like to do is to be able to pick up the positive side of the battery down here. So we're going to drop the flex circuit down in here, and we're going to pick up the positive side of the battery here, and we're going to drop off the negative here. And we're going to chase all that back to the other end where the charging and everything is. And here's a new zone for. Let me hide this.
You give them some detail of that processor board at the top.
Yeah, so now we're talking about putting the processor down here on this board. That's going to change. It's going to turn the voltage on and off. So we want to route some of this down into here, and this is our pad for our battery. And let me just see here. Let's take you into the 3D design and show you where it's at. But here's the flex circuit. Let's take a look at this real quick.
Which, to clarify, is not permanently attached to that PCB behind it. It would just
so it bends right here.
It would be a floating layer attached by essentially it'd be a friction connection.
Right. This is where we need our button to go on here, and then our little LED that's going to light up and do the light show. We want a multicolor LED out here. And then it goes back into the ZIF zone back here. So here's our ZIF connector. And that's where everything converges. So anyhow, we like to walk through this and go into the rest of the mechanical design so you can see where everything's at. So again, we've got everything being screwed on in the back here. So this assembly with this rubber overmold and this aluminum part right here screws on. And let's take a section view of this. Let's see here, and Chris, please comment as we're working through all this. So here's the end of the board assembly. So all this is going to be buried underneath the between the battery and the chassis. So this main chassis part is right there. If we hide this back assembly here, we hide that, and we hide this. Hide this.
Yeah, that gives you a little better view.
Right. So
you can see that profile again of that SD card. We're still having some issues fitting that in, but that we want to make the preparations for that technology to be included in the circuit, although we're not planning on implementing it in this initial model. We still want to make the provisions so that later we can simply add it as a drop-in feature.
Right, so we'd like to put this on the back side here. So some of these, like this ZIF connector here, if we take a look at this, it looks like it traditionally has a pass-through pin, and we want a surface mount onto this small circuit board along with our charging light and charging circuit here. I think Chris has got all that drawn out in the schematics.
More as a physical representation. The schema really just covers that, the section of the flex circuit itself.
Right, so there's the flex circuit underneath the chassis. Here's the rubber overmold. These molds are done. The chassis right here is going to have a little window that allows the flex circuit to come up, and the button is right there, and then the LED is right there, and then
there's our tactile micro switch. So that little tongue of circuit can sit outside the chassis under the overmold, where the tactile micro switch can get activated to fire the circuit off. Okay. And that's just tapping between that. That's our the low voltage or control portion of the circuit.
Okay. So then we want to be able to route things down onto the microprocessor here to be able to program it from the micro USB in the back. We want to be able to get through here, down here to be able to program that. And then that's going to flip the MOSFET on and off. So the MOSFET is down on this board, and that's actually over on the other side here, right over there. Right? Is that correct, Chris?
Yep. So that board 3 on top there, that's the one we're currently working on the redesign of that's going to incorporate the MOSFET, the Atmel Tiny 2313, I think, chip it is, and the other components of that.
Okay.
And that's probably where we'll later utilize those extra 2 channels that would be on the on the ZIF connectors for data purposes. And that would probably also something similar at the lower end board set for the micro SD card as well.
All right, so everything's sandwiched behind this board here. So let's just hide this. And what we're doing is our flex circuit comes over. Here it is, and it goes around, and it drops down onto here. And what we want to do is we want to pick up on the other side here. So we made a little hole for this flap to bend over here. But this is a trap right here that holds the ceramic in here. And so if we take a look at our ceramics for a second here, what we're going to do, let me hide this chip.
Yeah, you pull that those components out.
All right, here I'm going to hide the flex circuit. Here are these aluminum contacts here, and our heating element is buried up inside of here. So let's take a look at this.
There's the connection for the coil. If you can remove the ceramic or some of those extra layers, that would show the legs of the coil.
Right, so the coil is down at the bottom of here, and we're going to pick up these aluminum plugs that we're going to bang into the bottom of the ceramic there, and you can see our coil leg comes right out right
that
there.
Little red line there down in the bottom.
So we're going to bend it over, and then we're going to pound this aluminum coil in the or this aluminum plug in the bottom, and then our flex circuit is going to butt up against that stuff. So if we take and turn on our flex circuit again.
And this is one of our design considerations that we'd like your input on, is whether or not this type of friction connection will be feasible. We think that it will be so, considering that the connection that comes down on top, that atomizer, is actually it's a threaded, screwed part. And then from below, we have the spring loaded threaded end that pushes the battery up the chassis to that upper board set.
So this is flex circuit here.
Yeah, there we go. And you can see it's picking up that center hot pin and that outer negative ring to complete the circuit.
Right. So hopefully the flex circuit can handle this, and these are just going to be an aluminum contact, and we want this to be bare here. This can just be our graphics here, so when they open it up, they see the company's stuff there, because they're going to swap out this ceramic chamber.
Right. If you restore that the atomizer element there, that that entire section is a modular element that has a thread that screws onto the chassis itself. So when that portion of the atomizer was removed, that upper area of the flex circuit would be exposed, within the inner ring of the chassis there. Which another reason to put the print on there. A little extra advertising.
Okay.
I think that covers most of our design concerns, Pat.
Yeah, so we're a lot closer. I think now we need feedback from all flex circuits, and we'd like to get everything laid out where you guys do both the hard boards and the flex circuits, and we just drop the assembly into the chassis. So that's kind of where we're going. So if you get the SolidWorks files here, we'll send these over. What you're going to get is, let's see here.
I've also sent over Amanda the schemo that shows, and a kind of a crude physical layout that shows how that schema is incorporated into this larger physical construction.
Right. So everything's in the SolidWorks assembly. So anyhow, Why don't we leave it at this? My computer's running low on virtual memory, and we'll stop the recording here. So thanks, and we'll talk.